So first of all, we need to put a breakpoint. Actually, well, you won't see them anyway. And what's actually going to happen is now, because the way we're drawing this, these two are going to overlap in the center. So let's have a quick look and just get rid of those compile errors, and you'll see what I'm talking about. Oh, before we can continue with this, we actually have to get rid of all these other places where we have these old quadrants defined. So there's a bunch of them. First of all, we can just fix up this stuff. So this is just a little function I made to give the names of the quadrants. Very, very useful in some contexts, particularly when you're debugging and you just want to get the name. Because enumerations, you know, they're effectively integers, so you can't always just get a name. Okay, we'll just keep going. You should be able to see straight away what the errors are. Okay, there's a few errors there because it really didn't like that one. Okay, so we're now in another source file, the composite input model for select weapon. That's the one that I'm going to use later on to allow you to pick a weapon. And this one is asking in its touchdown method, which you haven't seen before. It's simply asking the player if this quadrant contains this screen point. So there's this concept of a weapon quadrant, which is probably a bit redundant. So what I'm actually going to do is I'm just going to comment this out completely. For now, we'll revisit this class at a later stage. We haven't even done the weapons yet, so that's cool. And that's the same error. Where's the next error? Okay, we're gonna get the same sort of thing in a few places where these old quadrants are referenced. So for now, we'll just uncomment them. They're all being used for features which we haven't even really implemented. Now this one is going to be a little bit more interesting because this is the boosters. So we're going to have to change this now that we've made these new quadrants. First of all, the whole concept of the weapon quadrant no longer exists. So what we're actually going to do is remove that whole statement, that and. So we're just going to comment out that whole line actually. I don't like using these block comments because they tend to make it difficult to comment out other things. And this is actually doing quite an interesting test. It's saying, is the player touching somewhere in the lower quadrant of the screen, which is not what we want. So we're going to have to revisit this whole thing. It won't take long. What we really want to do here is we want to restrict these movement touches to the left quadrant only, not one of the lower quadrants. And now, have I removed enough brackets? Yes. Okay. So if one of the lower quadrants is touched, and you know what, we're just going to remove that because it makes the if statement a lot easier to read. And we probably don't need quite so many brackets anymore. So if you're not aiming, which means you're not busy firing a weapon, not really applicable right now, that can't even happen right now, and that you have touched the left quadrant, then we can go into this lower quadrant touch change. So we can actually change that. So this is if you've done the left quadrant. So here's another test now, and I'm not really 100% sure. Okay, I know what's happening here. Okay, this whole thing should be removed. This is an old thing where you could swipe on one of the other quadrants and start dragging and it will move across. But we're going to restrict initially the player to this left quadrant. So if you recall from our little concept, this is actually a case where I had 4 and you could start sweeping from the bottom quadrant, but that no longer applies. Only touches that happen within the movement quadrant, which is the left side of the screen, should start movement. So that's what that used to do. So we're going to get rid of it because we don't want that. So we only want this to go into the touch state when you're in the left quadrant. In fact, now this enum is now incorrectly named because we no longer have any touch concept as a lower quadrant. So let's change that. So this is the boost and it only applies to the left quadrant, so we're going to change it to be left quadrant touched. So we're also no longer waiting for the upper quadrant touch. So we could probably, in fact, go straight in. We can eliminate this entire state because we just want to start boosting straight away. We're no longer waiting for it to cross into another quadrant either. So it's all just going to be very quick, sort of instantaneous. Now, there's going to be other errors, so let's get rid of them too. So that was all in the handle touch down, which is when you press your finger on the iPhone or on a tablet or other sort of touch device. The next function you need to deal with is when the finger moves, which is the handle touch move. This gets called usually by iOS or something like that. So in this one, in our previous code that we wrote, if your finger is already down, which is what happened up here, then it would enter into a new state. So I really don't think that we need this particular switch anymore at all. I think we can get rid of that. And as you can see here, this was sort of waiting for it to cross into a new quadrant earlier. It's sort of a historic function. But the important thing here is not this test. Well, it is kind of important because of the historic value of it. But the important thing is that it saves the current touch point. and then it enters the state. And if you recall correctly, we're already doing that up here because we changed it to remove this other state. So what we need to do is move that into here where we initialize the state, because this current touch point is very important for determining how much you're boosting and stuff like that. So that, once we've done that, and because this no longer exists, we can actually remove this entire branch too. So the switch just becomes the one state. If you are boosting, the current touch point is this. So the current touch point gets updated once per frame. That's actually not correct. I believe that should be changed, because if you remember earlier, in here we had the current touch point and the start boost touch point. They're separate. Like, this should only ever be where your finger went down. This is where your finger is at any given point in time. This is when the whole operation began. So we're actually initializing the wrong variable up there. And that may have been a bug actually in the earlier code. It's surprising to see that I wrote that code. I'm not really sure why. Of course, it's over there already. So we don't even need to do this. All we need to do is make sure it gets updated every frame when touch move happens, and that's fine. So now your obvious question is, when you're on a touch device, where is this guy used? So I'll show you where we use it. It's used in update. So if you look at update, this is called once a frame, no matter which state you're in. If you're in the boosting state, which could have been initiated by touchdown, depending on where your finger pressed, then it's actually going to compute the distance from the center of the player. So we need to change that. And what it used to do with that distance from the center of the player is create a force vector, which it would apply to the player. So we need to change that, because we sort of assume that the distance from the center of the player is being used for the boost, but that's not really correct. What we need to do is use the distance from the previous touch point. So let's rename this variable to reflect that touch vector. So it's a vector based on the touch magnitude. So we'll call it touch magnitude vec. And the current boost point is still valid, so we want to use the delta between the current touch point and the touch start boost point, which is saved at the beginning of the boost when you put your finger down. And that gives us a vector, because the iVec2 has an operator, has a subtraction operator. So we can use that. And you can see this is really, really old code, because I used to do, in the SIO2 engine, I used to do some crazy conversions in between different coordinate spaces. But actually now we can change that, because this can just be the x. So it is applying it to the y, which is right. And in our engine, y increases, so we want it to move upwards, which is fine, and that's actually what it's doing. And this divide by 50 is pretty arbitrary. What we should do is turn it into a float, into a const. So we can call it touch boost factor, or actually touch boost force, instead of 50, which is just like a magic number, and I hate magic numbers. Divided by touch boost force. That x is an integer. Let's turn that into a float. And then this becomes a factor, so we're actually multiplying it by 50. So touch magnitude, let's say the screen is, we need to look at this a little bit more closely, because let's say, if you look at our concept, let's say that the screen is, say, 400 pixels high by 400 pixels wide and 200 high. If I swipe my finger from the bottom halfway up, that's going to be about 100 pixels movement, and that's quite an easy sort of figure. It may even be more than that. For instance, on the iPad, it would be huge. So what we actually need to do here is compensate for that, because on bigger touch devices, that delta is going to be bigger. So in later sessions, we're actually going to have to create another constant which we can set externally to this whole piece of code in our CFG file for the particular platform, where that vector can be scaled based on the resolution of the device, because we don't want somebody on the iPad being able to boost incredibly high. We want the game experience to be quite similar in that aspect. Like, your movement will be very similar across all the platforms. But for now, we'll just use this. That's good enough for now. And it's multiplying by 50, so 100 times 50 is a pretty large value and a gigantic force in the game. What we actually want is probably just to start off with 0.5, which effectively divides it by 2. So if you remember earlier in our boost, the kind of forces we were applying, 70 was giving quite a nice boost. So that's quite a different factor to this boost force. As you'll see later on, we can't really treat them as one and the same thing. Maybe later on we could find a way to bind them together, but I think they need to be treated differently because the hardware is so different. Okay, so that will be every frame boosting, adding the touch boost force based on the vector computed between the original start point, which would be that one, minus this vector, which is wherever your finger is at that point in time before you release. So you can keep holding your finger and you'll keep moving upwards. That's the whole goal of this. And when you do that, it flips into another state, which is the no touch state, because that it actually gets a callback when your finger is released. It goes into no boost, and you don't keep hitting this. So that's very simple to understand. I think that'll cover a lot of the compiler errors. Let's just see if there's any other classes. I think so. So let's just see if that compiles. Eventually we're going to have to move on to the device. Okay, that succeeded. We'll just quickly run it to make sure that everything is still kosher on the PC. Nothing should have changed based on these changes on PC. It should still all be the same. Oh, we've got an error. Oh, we have to call this IW2D init function. So that's quite easy to fix. We just need to go and add that in. So as you can see, as soon as we start these 2D line drawing things for our little quadrants, bang, it dies. Because we need to call that function to set up that particular framework. I'll just put a comment in there because I just noticed that I have no idea what that actually does unless I have a comment. And the place to do this is in RCJ's main source file. So that's just in here, in RCJ. There's a whole bunch of systems that get initialized in here. Here it is. Okay. So as you can see, there's a place where 2D init. I believe you also have to call the terminate. Yes, there's also a terminate. And that would be just in the reverse order to what it's initialized, which is always a good sort of practice. And let's just check that that works. So you see how good it is. Like if we'd actually deployed to the iPhone right then and there, we would have had a weird crash and we would have had to check the log and it would have been major drama. But now we just have to add in this little init function. And what actually has happened here is we need to add in this IW2D.h as well, just so that it knows to use that and so that it gets that function declared in that header file to call from the source file. Let's see if it runs. Okay. So it's a little bit difficult to see probably on the video, but if you look closely at the top here where it says the FPS, you can see it's drawing a green line, and immediately, because of the power of the simulator, this would have been quite hard to diagnose in the iPhone because it's got such a tiny screen. But if you look closely here, it's drawing some of our rectangles, but our rectangles don't appear to be the right size. So let's close that and have a quick look at the way. Actually, we should have put a breakpoint in, but anyway, let's go and look at the player where it draws these lines. And my suspicion is that these quadrant sizes are not correct. Left quadrant. It looks okay here, but I don't think they're being initialized to the right values. So we'll put a breakpoint in here too. And we'll quickly investigate why these rectangles are the wrong size. So we'll start the simulator. Okay. So let's just step through a few times.